So we are on page 13 of your Unit 7 packet on circles, and today we're going to talk about arcs and central angles. Okay, so we've discussed a couple of these topics before, so it's mostly review with a few new topics that we'll discuss to add on to our knowledge about arcs and how to find the measurement and how it compares to the central angle. So the central angle is an angle with the vertex at the center of the circle. So for example, if I sketch in segment DB and EP, those radii, I get that the central angle is angle DPE. To make it a little bit easier, what I'm going to do is go ahead and label that angle 1, so it's a quick reference for us. So an example of a central angle would be angle 1. Another central angle would be angle EPF, or we'll call that angle 2. And then we'll call angle FPC angle 3. We're going to add another point over to the left that is just below segment DP. And I'm going to try to make this slice look equivalent to angle DPE. So that when I reference it later, I'm going to make the assumption that it is equal. So this is angle 4. Okay, so those are all central angles that I've marked angle 1, 2, 3, and 4. So we can go ahead and call these are all central angles. And so a minor arc is an arc in which, for example, arc DE, we would name with the coordinate points of the ends of the arc, and we would put a little arch above DE to indicate that that is arc DE. And this next statement we already knew, arc DE, the measure of arc DE, which is an angle measure, is equal to the central angle, which in this case is the measure of angle 1. So quickly, what would the measure of angle 2 be equal to? So hopefully you said the measure of arc EF. Okay, and a major arc is defined as an angle measure that is related to the minor arc such that it's 360 minus the minor arc. So when I'm naming a major arc, I would, for example, let's say, to highlight it a little bit better, let's say that you wanted to name this major arc right here. Okay, I would first describe that as DE the same way, the endpoints, but I would pick F and C in between that to denote that you have a third mid value between D and E. And so that would tell me that that's the major arc if there's 3 letters. So I'm going to undo that highlight real quick and go ahead and say like the major arc would be arc DCE, which you would put the arc above that, similar to the way I did it there, or arc DFE is another way of naming it. And those mean the same thing, DFE. Okay, and lastly, the semicircle is an arc with a measurement of 180 degrees. Adjacent arcs are arcs that are right next to each other. So think of adjacent angles, adjacent central angles that have a common endpoint. So for example, angle 1 and angle 2 are adjacent angles with the common endpoint of E. Okay, so the arc addition postulate just says that if you have one slice of pizza and another slice of pizza together, you can add it so that you can find the measure of the angle measure of the resulting arc, the sum of the two. So for example, let's say arc DF, the measure of arc DF is equal to the measure of the two adjacent arcs, which would be the measure of arc DE plus the measure of arc EF. Okay, and then lastly, in the same circle or congruent circles, you would know that 2 minor arcs are congruent if their central angles are congruent. So if I knew that the measure of angle 1 is equal to the measure of angle 4, then my conclusion would be that arc DE is congruent to arc, and apologize, I forgot to add a letter. So let's go ahead and add a letter for arc, for this arc here to be named. Let's call that A. So to arc DA is congruent to arc DA. Okay, so on to the next page. I'm going to do a few examples and then have you guys go ahead and try the rest and then just check your answers. So for the first one, we are given circle C, find the measure of each arc. Notice that your notation, I want to point this out because later on it's going to make a difference. There is no M in front of the angle and there is no M in front of this arc. But in the directions, they did say the measure of each arc or angle name. So the assumption is that if they did not have that word measure, you would have to have that M in front of that to know that they're asking you to find the measure of the central angle value, the central angle, or the measure of the arc. Okay, so with that, now if I'm looking for the measure of angle PCQ, I see that that's the central angle to arc PQ, so my answer to that should be it's congruent, so 60 degrees. Whereas arc ST is not given, but the central angle is 45 degrees. So I can say that the measure of arc ST is also equal to 45 degrees. Okay, and then SQP. SP is the diameter of the circle, so arc SQP would be equivalent to the measure of that would be 180 degrees, since that's the diameter and it marks the arc length marks that of a semicircle. Arc SQ is the difference between 180 degrees and 60 degrees, so 120 degrees. Now I'd like you guys to hit pause and try the rest of the 9 through 13. I'm going to go ahead and write in the answers. Okay, hopefully you guys have had a chance to do the problems, double check your work, and if something doesn't make sense, feel free to shoot me an email, but these are the solutions. Okay, down below here we'll do 16 through 19 together. On 16, you're given that the major arc is 240 degrees. How do we find the angle 1? Angle 1 is the central angle to this arc right here. So that arc is the difference between a 360 and 240, which is 120. So the measure of angle 1 is equal to 120 degrees. We have on the next example that you have numbered angle 1 is equivalent to the adjacent angle right next to that, and then its adjacent angle to the left of that. So if this is a semicircle, then together that's 180 degrees. Divided by 3, measure of angle 1 is equal to 60 degrees. On the next example, again, you have this is the diameter. You know that this is 160. So then this measure of angle 1 must be 20 degrees to make up 180. And then on the 19, you have this is the diameter. This the measure of that arc is 40, so the central angle is 40, which is vertical to angle 1. So the measure of angle 1 is equal to 40 degrees. And then that is a linear pair to 2, or we could have seen that also going in this direction as well. So the measure of angle 2 is 140 degrees. Now on 20 through 25, we're going to finish up with these. You have a concentric circle. The key thing is that they don't mention the word measurement like they did above here. So we have to be careful. If we have an arc that says measure of that arc, then we can assume that they're talking about the angle measure. But this right here, this notation arc AB, that's the arc length. That's how long, that's a portion of the circumference if you remember from the previous unit. So let's start with 20. The measure of arc BC is 45 degrees. So the measure of arc BC, we can make that assumption because we have here, this is 90 degrees. So this must be 90 degrees. It's a linear pair. And if we divide that in half, we can conclude that this is also 45 to make up the central angle of 90 degrees. So this is true. Arc AB is congruent to arc VW. Again, they didn't talk about measure of arc AB, which is an angle measure, but the arc length. And that length, let me change the color. This length is different from this, from arc VW, so this is false. Okay, a measure of angle DNC is 90 degrees. That's true. That's the central angle. Measure of arc XY is equal to 45. We can see that that's not true. It should be 90 degrees. So false. Okay, no mention of measure. So this is arc length. Arc length VW is congruent to arc length WX. And that is true. The length of those arcs are equivalent because the central angle is equivalent. So true. Arc AED is congruent to arc VZY. And if you look at the length, which is what it's referring to, this length is different from this length. If you were actually to stretch those two out, they're different. So this is false. Whoops. So this is false. And remember, they're not talking about the angle of those arcs, but they're talking about the length of those arcs.